Hello everybody, my name is Andrea Cardoso. I am professor at Federal University of Fronteira Sul and I'm here to present the results of our work titled Resistance Training Reduces Serum ATP Levels, NTPDase and ADA Activities in Platelets of Hypertensive Women. This work was developed by me and by my colleagues Aline Mânica, Daniela Zanini, Sara Maciel, Leandro Manfredi, Jean Sevigny e Clodoaldo de Sá. Let's start by talking a little about hypertension. When we look at this map, we can see that the whole world has hypertension. I mean, there are just very few countries in light color that have less than 20% of their population with high blood pressure. And raised blood pressure is estimated to cause 7.5 million deaths, about 13% of the total of all deaths. Moreover, more than 25% of Brazilian population is hypertensive. The hypertension stage 1 in orange is now defined by a systolic blood pressure between 130 and 139 millimeters of mercury, or a diastolic blood pressure between 80 and 89 millimeters of mercury. Essential arterial hypertension is an independent risk factor for stroke, myocardial infarction, heart failure, and arterial aneurysm. And all of these complications are related to the activation of platelets. Purinergic signaling has a central role in the platelet aggregation. While ATP and ADP can act as a pro-aggregant agents, adenosine, which is the final product of ATP hydrolysis, plays an important role in the purinergic metabolism, inhibiting platelet aggregation and exerting a reduction of the vascular injury. One of the mechanisms by which exercise may exert its beneficial effects seems to be related to purinergic signaling. It was already demonstrated that physical exercise alters purinergic system components and in some situations and in some systems. And we have previously shown that moderate aerobic exercise prevents the augment in NTPDase, ecto-5-line nucleotidase, and ADA activities in platelets of hypertensive rats, which attenuated platelet aggregation related to hypertension. Taking this into account, we hypothesized that resistance training could act as an anti-aggregant agent in hypertensive women, and the underlying mechanism could be related to the modulation of purinergic signaling. Thus, the aim of this work was to evaluate the effect of 6 months of resistance training on purinergic system components in platelets and on hemodynamic and anthropometric parameters in hypertensive women. The study was approved by the Ethics Committee of the Federal University of Fronteira Sul. To answer our questions, we recruited a total of 59 middle-aged women divided into 2 groups, normotensive group and hypertensive group. The normotensive group was composed by 28 sedentary, healthy, and non-smoking women. The hypertensive group was composed by 31 sedentary, non-smoking, and clinically stable women. Both groups, hypertensive and normotensive, were submitted to 6 months of resistance training. The aim of the resistance training protocol was to increase the muscle strength. The data collection was performed before, after 3 months, and after 6 months of the resistance training protocol. After the blood collections, serum was used for the determination of ATP levels. The platelets were used for NTPDase, ecto-5-line nucleotidase, and ADA activities determination by colorimetric methods. The anthropometric measurements included height, body mass index, and body fat percentage. For blood pressure measurements, a mercury column sphygmomanometer was used, and the heart rate was measured by using an automatic monitor. Here we can see a schematic representation of the whole protocol used in this study. At day 1, we performed the first blood collection. At the day 8, we carried out the adaptation phase for the resistance training protocol that lasted 3 weeks. At the day 29, we started the resistance training protocol. After 3 months of the beginning of the resistance training protocol, we carried out the second blood collections. At day 209, we finished the resistance training protocol that lasted 6 months. At day 211, we performed the third blood collections, the anthropometric measurements, and the blood pressure and heart rate assessments. And after that, the blood sample was analyzed in our laboratories. After all of the analysis, here we can see the results. As we can see here, the unique variable that changed between groups and after resistance training protocol was the systolic blood pressure. Systolic blood pressure reduced after 6 months of resistance training in hypertensive group. Here we can see the results related to the levels of extracellular ATP. Black bars represents control group and gray bars represents hypertensive group. Hypertensive group had higher levels of ATP in the pre-test and after 3 months of exercise compared with the normotensive group. However, in the hypertensive group, after 6 months of resistance training, a reduction in serum ATP levels can be observed when compared with the pre-test. There were no changes in the normotensive groups. Regarding the ATP hydrolysis, it can be noted that hypertensive group shows an increase in hydrolysis when compared with the normotensive group. After 6 months of resistance training, a reduction in ATP hydrolysis can be observed in the hypertensive group when compared with the pre-test. There were no significant changes in the normotensive group. According to the hydrolysis of the ADP, it can be perceived that the hypertensive group presents in the pre-test an increase in the levels of hydrolysis of the ADP compared with the normotensive group in the same period. In the hypertensive group, after 6 months of resistance training, there was a reduction in the hydrolysis of ADP when compared with the pre-test. Related to AMP hydrolysis, in the hypertensive group, we can see an augment in AMP hydrolysis at the pre-test, and exercise was able to reduce AMP hydrolysis in the hypertensive group. Regarding the ADA activity, it's observed that the hypertensive group had an increase in ADA activity in relation to the normotensive group in the pre-test. After 6 months of resistance training, a reduction in ADA activity was observed in the hypertensive group when compared with the pre-test. This result suggests a modulation in platelet activation in hypertension that favors pro-aggregant effects. After 6 months of resistance training, purinergic system components of hypertensive group were similar to normotensive group in platelets, demonstrating that resistance training was able to modulate platelet activation. We have performed some correlations between almost all of our variables. Here we can see that a positive correlation was found between blood pressure and enzyme activities, between blood pressure and levels of ATP. And what's very expected, we also saw a positive correlations between NTPDase activity and ATP levels. Herein, we showed that hypertension led to an increase in ATP levels and in ecto-5-line nucleotidase activity, linking purinergic signaling and platelet aggregation in hypertensive women. Systolic blood pressure positively correlates with NTPDase activity and ATP levels, demonstrating that purinergic signaling is one of the mechanisms underlying hypertension. Exercise promoted a lowering effect on systolic blood pressure reduced ATP levels, NTPDase and ADA activities in platelets of hypertensive women. We can suggest that ATP generation during hypertension acting via P2 receptors in platelets may play an important role in platelet aggregation, and exercise is able to reduce the increased ATP levels and signaling seen in hypertensive women. In conclusion, our finds demonstrated the relationship between purinergic signaling and platelet activation in hypertension and suggests that resistance training serves as a tool to reduce platelet aggregation in hypertensive women by modulate purinergic system. Thank you very much.